Welcome to Robbie's Office Hours. Buckle up for this one. This one's going to be a little rough, okay? So, angles and dot products. So there's a relationship between dot products and angles between vectors. But the question is, well, what is it and how do I get to it, okay? So fair warning, some trigonometry is showing up, but we'll get through it. Don't worry about it, okay? So we're going to start with the following picture. If I start with here is u, okay? And I start with here is v, something like that, okay? Then remember, if I move v, if I slide it over here, then I know that this diagonal of my parallelogram will give me u plus v, but I know that this right here will end up giving me u minus v. Okay, so that's my corresponding triangle. Well, if that's u and that's v, and I want to know what is the angle between the two, okay, then I can use the law of cosines. All right, so you scour your brain, you realize, I never remember this formula, you join the rest of humanity and say, none of us remember it, so you look it up and you figure out, okay, well, what does this actually say? It tells you the following thing. It says that if I take the length of the side opposite theta, I take the length of this, remember that's the norm, okay? If I take the length of that squared, that will be equal to the length of this side, which is u, squared, plus the length of this side, which is v, squared, okay? And then there's the cosine part. So minus 2 times the length of u times the length of v, multiplied by the cosine of the angle between the two, okay? The formula that everybody remembers and, just loves the most, which is not the true statement, okay? So anyway, how do I figure out what can I do with this particular equation at the end of the day? I want to figure this out. Well, let's go back to the dot product, okay? Remember that the norm of a vector u is equal to the square root of u dotted with itself, okay? So in particular, if I square both sides, I can say that u, the norm of u squared, is equal to u dot u. So what can I say from up here? Okay, starting with this formula, I can say the left-hand side is what? It's the norm of a vector squared. Well, the norm of a vector squared is equal to the dot product of the vector with itself. So this I can really say is u minus v dotted with u minus v. Okay? You with me? That's what the left-hand side is right there. Okay? The norm of a vector squared is the dot product of the vector with itself. And that has to equal, okay, what am I going to get on the right-hand side? Well, the norm squared, again, is u dot u. Okay, so that's u dotted with u plus v dotted with v. Okay, now because these norms are not squared, I'm not going to write them in terms of dot products. I'm just going to leave them alone for right now. Okay, so this is minus 2 the norm of u, norm of v, cosine of theta. That's what I get. Okay? So now the majority of the work is going to be done in working out the left-hand side. Now the dot product plays the role of kind of like distribution in some sense. Because these are all real numbers, okay, this is going to be over the real number line, then I can do the following things. So I kind of think of this as u dotted with u, so I'm going to get u dotted with u, okay, that's this one. U dotted with minus v, okay, minus v dotted with u, okay, and then minus v dotted with minus v, so minus v dotted with minus v is equal to this thing up here. Okay, so again, this is just the left-hand side. I'm just working this out right here, okay? And so what do I notice? I see a u dot u, okay? I see a u dot minus v and a minus v dot u. Now, over the real numbers, these two things are the same thing. These two things are the same thing. So what am I going to get? U dotted with u minus 2u dotted with v. Okay, I'm going to get 2 copies of those. Because u dot minus v is the same as minus v dot u. Implicitly, what I'm saying is u dotted with minus v is minus u dotted with v, okay? And if I take u dotted with v, that's the same as v dotted with u. Because we're over the real numbers, I can just switch their ordering. Okay, so that's how I'm combining those two things. And then minus v, the minuses come out. Okay, check the video on dot product algebra, if you will. So I have negatives that are going to come out, negative, negatives, positive. So this is plus v dotted with v. Okay? That's what this thing is equal to. And again, that whole thing's equal to this on the right-hand side. So let's finally write out what is this entire thing so that we can see what's going on. Okay? So on the left-hand side, I have what? I have u dotted with u minus 2 times u dotted with v plus v dotted with v is equal to, remember I still have this on the right-hand side, so I'm going to have a u dotted with u. I'm going to have a v dotted with v, and then a minus 2 norm u, norm v, cosine of the angle between the two vectors. Okay, and I step back for 2 seconds and I say, oh, cool, well I have a u dot u on the left and a u dot u on the right. Well, u dot u is just a number, so I can cancel that on both sides. Okay, and I see I have a v dot v and a v dot v, so those cancel. And so I'm really left with what? Minus 2 times u dotted with v is equal to minus 2 norm of u, norm of v, cosine of the angle between the two. Now let's check and make sure all of this makes sense. Cosine's a number, norm is a number, norm is a number, negative 2 is a number, dot product is a number, negative 2 is a number. If I divide both sides by negative 2, then I'm left with the formula that we were aiming to get, which is that u dotted with v is equal to the magnitude of u times the magnitude of v times the cosine of the angle between the two. Okay? That's the formula that we were after, and giving us the relationship between dot products and the angle between the two vectors. So what this says is, look, if the angle between the two vectors is 90 degrees, or pi over 2 radians, okay, 90 degrees, cosine of 90 degrees is 0. So in particular, if theta is equal to pi over 2, i.e. they are orthogonal vectors, they're perpendicular to each other, okay? Then u dotted with v is equal to 0. Okay? So in a previous video I mentioned that the dot product allows us to say something about when two vectors are going to be orthogonal to one another, and this is how we were getting at that particular thing. All right, I know this was a derivation, there weren't examples in this particular video, but I hope this is helpful in terms of showing you how to take definitions in terms of the dot product and the norm, and to apply something from trig that, to be frank, nobody really remembers, the law of cosine, and then we bring that together to get a formula for the dot product and the angle between vectors. All right? You know the drill. Like, subscribe, ask me questions in the comments, and we'll keep going along the linear algebra route.